minimum cost. The physical characteristics of wastewater. The physical characteristics of wastewater include those items that can be detected using the physical senses. Order. Fresh domestic sewage is almost odorless. Septic or stale sewage is putrid in odor, which is due to the generation of hydrogen sulfide during anaerobic decomposition of organic matters. When industrial effluent is mixed, it gives characteristic odor to the sewage. Physical characteristics. The next physical characteristic is color. Color of sewage indicates its strength and age. Fresh domestic sewage is gray in color, but septic sewage is dark in color. The color of fresh sewage is yellowish gray to light brown. When industrial effluent is mixed, it gives characteristic color to the sewage. Turbidity. Sewage is highly turbid. Turbidity of sewage is due to dissolved substances, colloidal matters, suspended solids, and microbial cells. Temperature. Temperature of sewage is slightly more than that of water because of the presence of industrial sewage. High temperature of sewage is due to evolution of heat during decomposition of organic matter in sewage. Chemical characteristics of wastewater. Sewage contains both organic and inorganic chemicals in addition to various gases like hydrogen sulfide, carbon dioxide, methane, ammonia, etc. that are formed due to the decomposition of sewage. pH. pH is used to describe the acid or base properties of wastewater solutions. The pH of sewage is initially high and drops when the sewage becomes septic but increases again with the treatment processes. Dissolved oxygen. Wastewater that has dissolved oxygen is called aerobic or fresh. The solubility of oxygen in fresh water ranges from 14.6 mg per liter at 0 degree centigrade to about 0.07 mg per liter at 35 degrees centigrade at 1 atmospheric pressure. Oxygen demand. It is the amount of oxygen used by bacteria and other wastewater organisms as they feed upon the organic solids in the wastewater. BOD, it stands for biological oxygen demand. It is defined as the amount of oxygen required by the bacteria while stabilizing decomposable organic matter under aerobic conditions. It is written as BOD or BOD 520. Let's define it. It is the amount of oxygen required by aerobic bacteria to decompose stabilized the organic matter at a standard temperature of 20 degrees centigrade for a period of 5 days. For domestic sewage, 5 days BOD represents approximately 2/3 times to by 3 times of the demand of the complete decomposition. COD, chemical oxygen demand. By definition, the COD is the amount of oxygen required to stabilize the organic matter chemically. That is, the COD is used as a measure of the oxygen equivalent of the organic matter contents of a sample that is susceptible to oxidation by a strong chemical oxidant. Nutrients. These are life-supporting nitrogen and phosphorus, includes ammonia also. Toxic chemicals. Most industrial various types of various types of toxic chemicals, the discharges of which can be harmful to wastewater treatment processes. Biological characteristics. Bacteria. It's of two types, intestinal bacteria and real sewage bacteria. The intestinal bacteria, it's non-pathogenic intestinal bacteria. These are normal flora of gastrointestinal tract of human and animals and enter the sewage together with the stool of the human beings. The real sewage bacteria, the natural habitat of this bacteria is sewage. Both aerobic as well as anaerobic are found in sewage. Aerobic bacteria play important role in oxidation of organic matter during aerobic process. Algae. Some algae found in sewage includes chlorella, Formidium, Althorax, etc. Algae are used in trickling filter in sewage treatment plants. Fungi. The fungi like Fusarium and Sporotrium are found in sewage which play important role in trickling filter. Virus. Some viruses causing human disease such as poliovirus, rotavirus, hepatitis A and E, etc. are found in sewage which get access through stool of the patients. So, different tests on wastewater sample. We can conduct pH test. pH meter is generally used for measuring the pH of water sample. pH value is the negative logarithm of hydrogen ion concentration in the wastewater. Total solids. Total amount of solids present in given sewage can be determined by evaporating a known volume of sewage sample and weighing the dry residue left. The quantity of suspended solids can be determined by passing a known volume of sewage sample through a glass fiber filter apparatus and weighing the dry residue. So the quantity of dissolved solids is calculated as dissolved solids is equal to total solids minus suspended solids. Chloride content. Chlorides are derived from the kitchen wastes, human excreta and industrial discharge. The chloride content can be measured by titrating the wastewater with standard silver nitrate solution using potassium chromate as indicator in the test. Similarly, test for nitrogen content. The nitrogen content may occur in one or more of the following forms: free ammonia, organic nitrogen, nitrates and nitrates. The presence of nitrogen in sewage indicates the presence of organic matter. presence of fats, oils, and greases. These are derived in sewage from the discharges of animals, kitchens of hotels, and from industries. In order to determine the amount of fats, greases, etc., a sample of sewage is first evaporated. The residual solids left are then mixed with ether, and the solution is then evaporated, leaving behind the fat, grease as a residue. Biological oxygen demand, BOD. It's defined as the amount of oxygen required by the aerobic bacteria to fully decompose the organic matter. The instrument directly records BOD reading at every 24 hours. After that, the bottles are preserved in the incubators for days as per need of the study. Wastewater treatment procedures. So, 3 or 4 stages are there for wastewater treatment procedure. Preliminary treatment, it is sometimes considered as part of the primary treatment. So, secondary treatment, and if need be, tertiary treatment. So we shall discuss the various treatment procedures in the next lectures. For now, thank you very much. Please watch Wastewater.